Hello everyone. So welcome to Geeksforgeeks Computer Science. Myself Saptarshi Banerjee. Okay. So we'll be studying query optimization today. So just let me check if my audio and video is properly visible or not. Okay, just to let me give me a minute. I'm just checking it. Okay. Well, yeah, I guess it's working. Okay. So without any delay, let's start our today's topic. Uh, so today we'll be studying about the query optimization part, and I must tell you one thing that this query optimization has been asked in 2020's paper. Okay, so though it was not mentioned in the GATE syllabus clearly, but GATE question has been asked in this in 2021 in 2021 first paper this query optimization has been asked. Okay, so you need to focus on this part, and before everything I just want to share a very happy news with all you that okay, let me announce the news with all of you just by my slides. Okay, so till now what you are seeing that Saptarshi Banerjee, and I'm studying at IIIT Hyderabad. Okay, so recently I have been selected in one of the premier institute, which yeah, obviously IIIT Hyderabad is one of the famous institute, but let's see here. Okay, so yes, I have been selected in ISI Kolkata also. So I'll be joining ISI Kolkata with all your love. And thank you for your support. So that's all from my announcement. So I'll be very happy if you want to pursue your studies in ISI Kolkata, and we'll be meeting you soon. So if you have any doubt regarding ISI Kolkata, you can directly mail me, or you can ask me in the comment section or in your LinkedIn. Okay. So without any further delay, so let's start our today's topic. Okay. Yeah. So okay. So what is query optimization? Right? What is query optimization? A single query can be executed through different algorithms or rewritten in different forms. Okay. So in query optimization, basically, why we need that? First of all, let me tell you what is query optimization. Okay, let's tell you the definition of query optimization first. Then you can understand what is the need of it actually. Okay. So query optimization means, let's say you are doing something like. This is basically needed in case of query, like when you are doing some SQL. So while doing this, you will be needing this. So what is the actually like this? So like if you are selecting select star from employee database, okay, where the salary, is greater than equals to 1 lakh. Okay, so let's say this is one of your query. Okay, so you have a database table. Where there are, let's say, 10,000 tuples are there. Okay, so in this 10,000 tuple, only let's say 5,000 people are having salary greater than 1 lakh. Okay, only 5,000 people are having salary greater than 1 lakh. So what this query returns? So this query returns all the attributes having the salary greater than 1 lakh. So the number of tuples here will be 5k, right? Number of tuples will be 5k, right? So why we need actually this query optimization? So let's say this is a simple query, okay, but if we want to do something like where the salary is greater than, let's say, 1 lakh, and we are doing something like where age is less than 30, okay, so our query consists of two prepositions, and two prepositions are conjuncted, okay, so there is a conjunction between these two prepositions, not preposition, I'm not mentioning it like it's a proposition, okay, it's a proposition which are actually bound with one conjunction, that is and. So what we are going to get, so we are going to get the tuples where the salary is greater than 1 lakh and also the age is less than 30. So we are going to get that. So what happens? Let's see here. So you are having a table. Okay, you are having a table. This is an employee table, and there is having 10k of tuples. Number of tuples are 10k, and there is a age attribute and there is a salary attribute. Okay, so in this age attribute, let's say you are having 30, 40, 50, likewise, and 20 also, let's say, okay, so the number of tuples with, let's say, age less than 30 is let's say there is 7k tuples, okay, and number of tuples with salary greater than 1 lakh is, let's say, 5k, okay. So when you are doing the proposition like we are having salary is greater than 1 lakh and the age is less than 30, okay. So when we are doing this, so what we are doing, so first we are checking if the salary is greater than 1 lakh, then we are retrieving these 5k tuples, and after that we are actually after end of everything, and the people are having the age less than 30 and let's say salary greater than 1 lakh, the number of such tuples is equals to, let's say, 2k only, okay. So our output consists of number of tuples will be only 2k, right, only 2000 tuples will be there in our output, okay. So as you can see, there are two propositions, right? So in these two propositions, how we can minimize our disk access. So this is what the query optimization is. So you can see here, if we are doing the salary greater than 1 lakh, we are retrieving 5k tuples first. And after retrieving that 1 lakh salary, greater than 1 lakh salary, we are retrieving this age is less than 30. Okay. So what we are getting a chunk of tuples, and this chunk of tuples is nothing but 5k tuples, only 5k tuples, and within this 5k tuples we are checking if the age is less than 30. So we need to check only this 5k tuples here. So first we need to check all the 10k tuples, and inside the 10k tuples we need to check this 5k tuples, okay. So this is our cost of doing the query. But let's say if you are having age is less than 30 first, and then you are having salary is greater than 1 lakh, what you are going to do, so first of all you are going to retrieve all the tuples that are having age less than 30. So first of all you are going to retrieve all the tuples which are having age less than 30, and let's say, as we have seen that we are having 7k tuples, such tuples, so we are going to retrieve 7k tuples here, okay. And after retrieving these 7k tuples, we have to iterate over all the 7k tuples, and we have to check whether they are having salary greater than 1 lakh. So in this case, first we are doing a 10k operation, then we are doing a 7k operation. In the if the age is first, if age is less than 30 and salary is greater than 1 lakh. If this is the case, if you are doing the age calculation first and doing the salary calculation next, okay. So in this case we are having 17k. we are having 17K cost. But if we are doing the salary first, if you are doing salary greater than 1 lakh, and then we are doing the age is less than 30, in this case only, in this case, we are retrieving first 10K tuples and then we are doing 5K tuples operation. Okay. So in this case, we are total having 15K operations, right? So which one is lesser? So obviously this one is lesser. So this is our optimized. So we can say that this is our optimized query. This is our optimized query. Okay. So this is what query optimization actually means, right? So it is saying what a single query can be executed through different algorithms, right? So what we are doing here, we are just shuffling the propositions. First, we are having the first in the algorithm one. In the algorithm one, let's say we are having the salary first and then age, and in algorithm this is the algorithm 1, and in case of algorithm 2, we are having the age first and then the salary calculation next. So, which one of the algorithms are actually faster? The algorithm 1 is actually faster. So, we'll go with the algorithm 1. So, what it is saying here, so a single query can be executed through different algorithms or rewritten in different forms or forms and structure, right? Hence, the question of query optimization comes into the picture, right? And most importantly, both the algorithms should give the similar result, right? So both the algorithms should be serializable only, right? So both the algorithms should be serializable only, then we can apply this query optimization part, right? So which of these forms or pathways is the most optimal? So whenever we are getting multiple algorithms to satisfy a query, satisfy a serializable result of a query, then we need to come up with the optimized version. You may have seen that we are doing some optimization first in case of DSA. What we have to do first, we write the recursive solution, right? If the recursive solution contains some but if it is containing some overlapping substructures, if it is containing some overlapping substructures, then we go to some steps called like memoization. Memoization can be done, and this memoization can be of two types. One is top down and other one is bottom up. Top down, sorry, and other one is bottom up, and one of them is called the dynamic programming approach. The dynamic programming, or the DP, most famously called the DP programs. So actually what we are doing here, so we are having a recursive call which is having an order of 2 power n solution. So after that we are doing the memoization where we are actually doing it in linear time or some quadratic time or cubic time. So it may be n or n cube or n square, anything. And in DP we are actually using some extra space, but we are saving our exponential time. So this is actually optimization algorithm. So here also we are doing optimization on the queries algorithm, where we are actually implying the query, and those queries should be optimized. And why they should be optimized? Why they should be optimized? Okay, let's see here. Okay, first of all, why we need actually it? Why query optimization is actually needed? Okay, so basically, in your college days, you may have seen some. You may have created some dummy database of student that is containing some maximum of 100 tuples or something like that. Okay, but in case of real life, let's say you are having millions or billions of users. Okay, so actually, in today's world, it is said that the data is the most important thing. It is more important than anything. It's more important than money also. Okay, so data is the most important thing. So whatever we are doing, the Amazon and Flipkart, or whatever they are doing, so they are retrieving our data, whatever we are searching, whatever we are buying. So they are entirely storing those data in their database. So these are called the big data. These are called the big data. Okay. So these big data are stored in very huge databases. So this huge database, zettabytes of database are there. Zettabytes of database. Some terabytes and zettabytes of database are there. So in these zettabytes of the database, if we are applying some query which are going to retrieve us in some, let's say, 1 hour, is this a very feasible or practical thing? No, it's not. So what we need to do, okay, my voice is not clear. Okay, let's see. Is it okay now? I'm not quite sure. Is it okay now? I think it's okay. Okay. If any issues happen, let me know. Okay. So okay. So there are zettabytes of data, right? Yeah. So in this case of zettabytes of data, we need a very optimized algorithm which can fetch this huge amount of database tables to us, and therefore we need some optimization on the query. Therefore, the need of optimization comes into the picture. Therefore, the need of optimization. And what are the types of query optimization what we can do? Let's see. So first of all, we can do analyze and transform the equivalent relational expression. So what I have done here. So in the previous example that I have given you, uh, let's say first we are having the age and then we are having salary, and then and in the algorithm 1 and in algorithm 2 we can just shuffle the salary and age part. Okay, so what we are doing, we are just analyzing and transforming the equivalent relational expressions. So this is a relational expression. What is a relational expression? And in the relational algebra, we can do select, and select like age is greater than 30, sorry, less than 30. And so this is a conjunction, and salary is greater than equals to 1 lakh. From the employee table we can do there. So in this way, this is like a relational algebra expression. Okay, so we just analyze and transform those equivalent relational expressions and try to minimize the tuple and column counts of the intermediate and the final query processes. Okay, so what I have discussed here, right? This is the first type. Okay, this is the first type. And what is the next type? So this is the called using different algorithms for each operations. These underlying algorithms determine how tuples are accessed from data structures and they are stored in indexing, hashing, data retrieval, and hence influence the number of disk and block accesses discussed in the query process. So this is something different, and I hope this from this type of query optimization you won't be getting question. Nonetheless, I'll be covering these two, but today we'll be focusing more on this part. So this transforming the query optimization of transforming the equivalent query into some other query so that we can optimize this. And this is something called we are having some nested join. We can there are different types of joining operation, nested join. We are having block nested join operation. So these are basically different types of algorithms. Loop nested join, then merge nested join. We'll be seeing this in the next class maybe, but these are not actually needed, I guess. But nevertheless, you should study this at least for 1 to 2 days only, because if you are just remembering how the process is working, then you can easily can solve this kind of questions. Okay, so these are the different types of algorithms, and this tells us how actually the data is retrieved. So the first type tells us going to retrieve what and how to minimize the number of count of operation. And the second process tells that in from the database table, how we are going to retrieve the data. How we are going to either we are going to retrieve the data by blocks or by actually by tuples, or actually we are going to retrieve them by a chunk of memory and then merge them together, or whatever we are going to do, we are going to tell them in this kind of naming conventions are used for those. Okay, so these are the types of query optimization. So we will be seeing the first type today. Okay, okay. So for this, for the query optimization, we need one thing that is called the catalog, and we need to store something, catalog information. So this catalog information is very trivial. So what they are saying that for a given relation R, we can store the following relevant information in the catalog. So whenever you go to the library, you just check the catalog where the book is and where the in which particular shelf the book is, and in which uh, of which author the book is written by. So you can find everything in the catalog. Similarly, whenever we are storing a table in a database, we are maintaining a catalog for that. We are maintaining a catalog so that every table that has been entered into the database is having actually a specific copy or specific entry for that. So, so what are the entries in the catalog? The first one is the NR, which is the number of tuples. Okay, so if it is having, let's say, 10,000 tuples, so our NR will be nothing but 10,000, right? So next one is BR. What it is telling? BR is the number of blocks containing the tuples of the relation R. So BR is nothing but, let's say, this is your hard disk, and this can be, I have told you that this can be divided into multiple logical blocks. This can be divided into multiple logical blocks, and let's say these are divided into four logical blocks. Four logical blocks. This is block 1, this is block 2, this is block 3, and this is block 4. Okay, and every block is actually containing how much, you'll be figuring it out on your own. So the entire tuple is 10k. Entire tuple is 10k, and this entire tuple is divided into four blocks. So BR will be here. So our NR is nothing but 10k. Our BR is nothing but 4, because the entire tuples are spanned into four blocks only. And the second one is the size of the tuples in bytes. So what is LR? LR is nothing but, suppose you are having a tuple like this. You are having an ID, then you are having an age, then you are having a salary, then you are having a phone number. Okay, so this is the entire the attributes of any tuple you are having. So in this ID you are having one, int is 22, salary is 1, phone number is something XXX. So this entire thing, let's say if we are calling this as tuple 1, so this tuple 1 is consisting of all this thing. All this thing is consisting of tuple 1, right? So the entire size of tuple 1 is actually the LR. So let's say if ID is taking let's say 2 bytes, if age is taking say 4 bytes, the salary is taking say 8 bytes, and phone number is taking let's say 1 byte. Okay, so the entire LR will be what? Entire LR will be 2 plus 4 plus 8 plus 1. Okay, so this can be 12 plus 4 to 14 plus 115, right? So our LR will be here 15 bytes. So actually, the size of one tuple is called the LR. Okay, the size of tuple in bytes. You need to think of this bytes. It is termed in bytes. Okay, and voice is not clear. Okay, bytes. You need to think of this bytes. But I think the voice is clear. It is coming clear to me. Hello, is it clear now? I hope it's clear. So let me know if any issues happen in the meet. Okay. Okay. So the next thing is AFER. AFER is calling the fraction or the blocking factor. So AFER is nothing but the blocking factor. We have seen about this blocking factor whenever we are doing the indexing, right? The blocking factor we have already seen. So what is the blocking factor saying? It is saying the number of tuples in a block, right? So what will be the blocking factor here? How much tuples is containing here? So we are having total 10k tuples, and this are divided into 4 blocks. Let's say. So we can standardize this thing by, let's say, 10k by 4. So if we can say that every block is having 2.5k of tuples. Only 2.5k of tuples is every block is having. So the blocking factor will be 2.5k, right? So this is the number of tuples that fit into one block. So this is called the blocking factor. And the final one, this is very important here. The V is called actually the distinct number of tuples, the number of distinct values of attribute X. Okay, what does it mean? So if you are having, let's say, salary. So in this salary, you are having, let's say, 1 lakh, 1 lakh, is all 1 lakhs, and then we are having 2 lakhs, 2 lakhs, 2 lakh, 2 lakh, and then you are having 3 lakh, 3 lakh, and all like this 3 lakh. Okay, so if we are told about what will be the V of salary in the relation R, what is this? So this is nothing but 3, because what are the number of distinct salary here we are having here? We are having distinct salary as 1 lakh, we are having 2 lakh, we are having 3 lakh. So the number of distinct salary possible is 3. So V of salary, so the notation is read like this: the V of salary, the distinct number of salary in the relation R. So this is nothing but 3. Okay. So this is the one thing. Okay. Okay. So this is quite important. This slide is very important. If you want, you can take a screenshot if you are seeing, or if you are having any copy and pen, you just note those down. I'll be explaining those, and just note this down, and you will be needing this. If you cannot remember the entire thing, just go through the entire thing just once a day, and will be solve like one to two questions on this, on every possible scenarios, and you will be quite familiar with the formulas. Okay. So the first thing is saying the number of tuples or the size estimation. So it is saying the size estimation in selection. So whenever we are doing a selection in our relational algebra expression, what will be the size of the output tuple? So we are actually having an estimate. It can be more than that, it can be less than that, but we are trying to generalize the thing. We are trying to find out generalized formula for everything. So first of all, we need to assume something, that is, attribute values are uniformly distributed. Okay. What do you mean by uniformly distributed? We are assuming that the values are actually uniform in the uniform distribution. Like if we are having 1 lakh salary and 2 lakh salary and 3 lakh salary, we are expecting this 1 lakh, if this 3 salary are there, if 1 lakh salary is 10 in number, then 2 lakh salary are also 10 in number, and 3 lakh salary are also 10 in number. So this is actually what uniform distribution means. Okay, everything is uniformly distributed. Okay, so the first thing is saying that the size of sigma of x equals to small x in the relation R. So what is this? It is nothing but it is saying that if you are having, so let's say, age equals to 30 in the relation R. So how many tuples we can expect if we are executing this query? If you are executing this query, how many tuples we can expect? Okay, so the formula telling here, it is nothing but n r divided by v of x comma r, where x is what? X is the tuple. X is the attribute we are searching for. So here x is nothing but age, because we are searching for age only. And so what it is telling, so if you are having, let's say, 100 tuples, 100 tuples, and we are having distinct age values in R as 5. Let's say there are 5 distinct age values. Let's say there are 20, 30, 40, 50, and 60. So these are the 5 distinct age values present in your database which are having 100 tuples. Okay. So how many people you can expect having this 30 age is equals to 30. So this is pretty straightforward, that if you are having 100 tuples and number of distinct age possible is 5, then you can obviously expect, and obviously you are having a uniform distribution. This is very important. You are having a uniform distribution, then you can expect that age equals to 30 is nothing but 20. So the number of tuples, so 20 tuples can be of age equals to 30. This is the possible scenario. Okay, so this is the first case. And the second one is saying that if you are executing in, let's say, age is less than equals to 30, age is less than equals to 30, then how many tuples you can expect? So this is nothing but, actually this is if you are familiar with statistical method, if you have done any kind of Python programming for statistical method, then you are quite familiar with this formula. This is nothing but the normalization formula, right? If you have ever done the statistics in your course or in your interest, then you are quite familiar with this. This is nothing but the something. Sometimes we replace this minimum with the maximum also, but in this case we are using the minimum. So what it is telling, let me give you an example. Let's say if you are having age is less than equals to 30, okay, and total number of tuples possible is equals to 100, right? And let's take this example only. So the different types of ages possible: 20, 30, 40, 50, and 60. So the minimum of age possible in R is what? 20, and the maximum of age possible in R is what? 60. Okay. So how many tuples you can expect to have age less than equals to 30? So it is nothing but 100 into the expected thing. What is your expected thing? That is 30. You are expecting age less than 30 minus the minimum value of the age, that is 20, divided by the maximum value, which is nothing but 60, and minus the minimum value, which is 20. So you can expect 100 into 10 divided by 40. You can expect 25. Almost 25 number of people is having. This is actually an estimate. This is actually an estimate. It can be more than that, it can be lesser than that also. But we are trying to achieve some expected value. We are trying to achieve some expected value. So this is, the entire thing is derived from the statistics. The entire thing you are going to be familiar with the statistics. This is nothing but statistics. All the formulas are derived from statistics only. Okay. So this is nothing but the, you can think of this is actually the average. This is the normalized value. This is the normalization. Okay. So these are the different statistical measures for finding the estimation. And the next one is telling about if you are having some conjunction. If you are having some conjunction of propositions, then we can apply this formula. Okay. Okay. Let me clear the year first. Okay. So let's say if you are having let's say age is equals to 30 and salary is greater than 1 lakh. Salary, if you are having that age is equals to 30 and salary is greater than 1 lakh, then what will be your expected answer? Okay, so what it is telling? It is telling that S1 into S2 into dot 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 Sn up to Sn and divided by the number of tuples to the power n minus 1. What is n minus 1? What is n minus 1 actually? N minus 1 is nothing but the number of propositions you are having. Number of propositions. So if you are having age equals to 30 and salary equals to 1 lakh, so the number of proposition here is 1 and 2. So your n value will be 2 here. Okay. And what is S1? So S1 is the cost of finding out the age equals to, so S1 is nothing but sigma of age equals to 30. And what is S2? It is nothing but sigma of salary is equals to 1 lakh. Okay. So you need to find out these two and then multiply the number of the size of each of them and then divide them by number of tuples to the power 2 minus 1. That is S1 into S2 divided by N. So this is your answer. If you are having three propositions, so in that case you will be having 3 minus 1, that is n to the power 2. Okay, so like this you need to find it out. Okay, so I'll be discussing one example also, so no need to worry. I will discuss a concrete example with this. Okay, so similarly we are having if you are having some disjunction between the proposition, then what is the scenario here? We are having it is basically from the number of tuples to the power the number of propositions, we are actually subtracting the entire thing. Okay, so it is nothing but what? It is actually the number of tuples minus the, think of it like this, theta 1 and theta 2 and theta 3 and theta n, right? So this is nothing but the size of theta 1 or theta 2 or theta 3 theta n. Why this is so? Because if you do this calculation, manual calculation, it is S1 into S2 dot Sn divided by nr to the power n minus 1. So if you do the cross multiplication here, if you take the LCM, you'll be getting nr to the power n minus S1 into S2. Okay, and so this is actually the complement of this, right? This is the complement of this. So it is actually nothing but the De Morgan's law. So what do we know by De Morgan's law? A or B complement is actually A complement intersection B complement, A complement and B complement. So this is the De Morgan's law, and from this De Morgan's law we are having this. Okay, so it is actually, if we are thinking about theta 1 and theta 2 and theta or theta 3 or dot theta n and entire complement of this, so it will be nothing but nr minus s1 by nr to the power n minus 1 into I'm sorry, n minus 1 into nr minus s2 into dot. Okay, so this is the complement of this, and if you do again the complement of this, you'll be finding out it will be nr minus this entire thing, that is nr minus s1 nr minus s2, okay, divided by nr whole to the power n minus 1. Okay, so if you do the take the LCM, it will be having nr to the power n minus nr n minus s1 into nr minus s2 dot divided by nr whole to the power n minus 1. So this is how this is entire thing is calculated. Okay, nothing but a De Morgan's law. Okay, and the final thing, this is pretty straightforward. So if you are going to find the complement of some query, let's say you are going to have age where the age is not equals to, okay, what is the not equals to sign in SQL? This is the not equals to sign. If you are not going, so in in relational algebra you can use any kind of sign, but the age is not equals to 30. So for this, you just need to find the number of tuples which are satisfying the age equals to 30 criteria first, which are the tuples satisfying this age equals to 30, and then you just need to subtract it from the entire tuple. You just subtract it from this. Okay. So after that, you'll be getting the. So this is nothing but the complement that I have mentioned you here. This is the complement of this. Okay. So we'll practice one question from this. My suggestion would be not to invest much time in this because this is not so frequently asked question. But as in 2021, one questions was there. I'm discussing this. But if you are preparing for let's ISI exam or TIFR question, TIFR exam, then this is a must know topic. Okay, this is the must know topic. And for ISI, I'm quite sure that you are going to get some questions from this query optimization because it is a statistical institute and all these things are actually derived from statistics only. Okay, so if you are preparing for ISI or TIFR, then study this in depth. Okay, and for projection, what is the thing? For projection, if you are doing the projection. If you are doing the projection like this, and you need to find the size of it. So AS is basically nothing but the size. It is nothing but the size. What will be the size after you do the projection? It is nothing but what? So you just need to know what this returns, what this projection returns. Projection actually returns. Projection does not return all the tuples you are having. Projection returns number of unique tuple, right? It is nothing but select distinct. It is actually equal to, it is a very famous question, right? It is actually what is pi equivalent to in SQL? What is pi equivalent to in SQL? It is not equivalent to select, but it is equivalent to select distinct, right? It is a very famous question. You can get it in any kind of, you know, what it tells, any kind of test series or any kind of interview, or you may face this kind of question. Okay, so this is nothing but select distinct. So if you are applying the pi, you are going to have the distinct number of attributes you are doing the pi upon. So if you are doing the pi, if you are doing the projection on this x, so you are going to get the distinct number of x you are having. Okay, so this is nothing but v of x. And what is aggregation? It involves the size of v of x. This is not a very famous thing. You can skip this aggregation. And the set union thing. Set union is pretty much straightforward. Set, what set is? Set is nothing but is. So you are having this set and this set. So if you take the union of these two, if you are going to take union of these two, what you are going to do? So if this is S1 and this is S2, so what is your union? S1 union S2 will be this part and this part and this part, and from that you are going to minus this one. You are going to take this one, you are going to take this one, and you are going to subtract the common thing from this. Okay, it is nothing but n of S1 plus n of S2 minus okay, n of S1 intersection S2. Okay, Srishti is asking there, sir, how to start SQL and Dbms. Okay, Srishti, are you talking about Gate or something for for interview purpose or for any job preparation? For SQL and Dbms, you can follow our lectures, obviously. For SQL, I would suggest, if you are going to want to master SQL, you first try to solve the questions from the book called Navate. This is a very standard book, and also for Gate also, this book is widely followed. This is widely followed book. If you want to master SQL, so you just try to solve all the questions in the exercise of Navate and after that you can go to any kind of online thing. If you can go to GFG also, you can get all the topics, and you can go to HackerRank. You can go to HackerRank and practice. There are a lot of problems in HackerRank in SQL. Okay, so you can practice them from easy to hard to medium. You can get every kind of questions there. You just try to do some hands-on experience on SQL. I'm telling this specifically for SQL only. Okay. And for Dbms, I think the lectures uh, taught here are sufficient for you if you want to crack the gate. And just study from this Navate book. This is very standard book, and try to do some previous year question. That will suffice your gate preparation. And for any kind of interview preparation, you just go to HackerRank and practice as much as SQL questions are needed. Okay. Okay. So set union is basically telling us no greater than NR plus NR2. So what is telling? It is like actually say size of R1 union R2 is actually less than or equals to NR1 plus NR2. Why less than equals to? Because for this one, you may need to subtract the intersection of these two. If we are having any kind of intersection between the table R1 and R2, then we may need to subtract things. So in that case, the number of tuples get reduced from this addition. Okay. And for set difference, what it is? Set difference is nothing but this is let's say A and B. What is A minus B tells? So we are going to take all the things from A and that are not in B. Okay, that are not in B. Okay, so it is actually the number of tuples that are in R1 actually. Okay, and maybe if there are some tuples which are getting the intersection from B also, if you are getting some intersection of B, you just need to subtract the tuples that are having the intersection. So it is nothing but n of R1 minus n of R1 intersection R2. A minus B. So it is obviously n of A minus B is obviously less than equals to n of R1, you can say. So that's why it is written that n of not greater than n of R1, right? How long is this class is taken? Okay, which class are you talking about, Rajdeep? Are you talking about these live classes or anything else? Okay, so this is the entire thing. You can write it down, Rajdeep. Which classes are you talking about? Okay, so we will see an example on the size estimation purpose. Okay, so this is a very question. Okay, this present class. Okay, Dbms. Yeah. So actually, I am teaching this subject from transaction management. I have taught this kind of things here. I have taught transaction management, indexing, and now I'm talking about the query optimization. So these are actually you can find this DBMS at 7 p.m. from Wednesday, to Sunday, and mostly in Sunday we discuss the previous year question we discuss. Previous year questions are discussed mostly on Sunday, and from Wednesday to Saturday we try to cover up the concepts. And you can find it from 7 to 8 p.m. Okay, in this Geeks Computer Science channel. And these are the topics that I have covered, and previously it was taken by Rohan Jaiswal, and he is currently in IIT Guwahati. So previously he has taught, I guess, ear diagram and normalization and the relational algebra. All these kind of things are already there in the playlist. You can go to the playlist and check this kind of thing. These are the concepts, and I have covered these topics also. So all the things are covered here. You can go and check in the playlist. Okay. So I hope you have got your answer. Okay. Let's focus on today's questions. Okay. So this is the question. I have taken only one question because this is not very famous question, and if you are going to do one or two questions are like that, okay, so you'll be quite familiar with this kind of formulas and this kind of topics. So this is a very straightforward type of question you can get. Okay, so it is saying that given a relation R with 60 tuples. So I have given you one tip in the first day, that whenever you are trying to read the question, just write the relevant information regarding the question in somewhere else, somewhere in your copy. So the first line gives us some information that given relation R with 60 tuples. So what it is telling, the A naught equals to 60. So just write it down while you are reading the questions. Okay. If R has an attribute age, so we are having an attribute age within the range of 20 to 30. So what it is telling, the minimum value of age is actually 20 and the maximum value of age is actually 30. Well, and there are 15 distinct values for the attribute height. Okay, so we are telling about that there are 15 distinct values of not age but height we are having. We are having 15 distinct values of height in R. So this is the notation of distinct tuple for attribute height, minimum of which is 70. So the minimum height possible, the minimum value of height is nothing but 170. Obviously, it is given in 170 centimeter in case, right? So you need to find out the size of the query. The query is telling it select age is less than equals to 23, and so this is a or height is equals to 170. So this is the query for which you need to find out the size. Okay. So what I have told you, that whenever this given this conjunction or disjunction, whenever there are multiple propositions, to be honest, so you just need to find the individual propositional size first. So there are two propositions. One proposition is sigma age is less than equals to 23, and the second proposition is sigma height is equals to 170. So this is easier to find. So what you need to do, you just need to find A naught divided by the number of distinct tuples, right? So this is the formula, and we are having 60 tuples and number of distinct heights we are having 15, right? So 60 by 15, and this is nothing but 4. Okay, and for this you need to find out what is the size of age less than equals to 23. So for this, what you are having, so you are having, right, nr into x minus min of x divided by max of x minus min of x. This is very easy to remember. It might seem very cumbersome to you, but it is actually the normalization formula. So it is very easy to remember. So what it is telling, we are having 60 tuples into, we are finding for what? We are finding x equals to 23 here, minus the minimum value is 20 here, divided the maximum value is 30. What we are doing? We are doing for age. So the minimum value of age is 20 and the maximum value of age is 30. So it is nothing but 30 minus 20. So it is actually 60 into 7 divided by 10. So it is actually 6 into 7, right? So it is nothing but 42. So the first one is giving us the size of 42 and the next one is giving us the size of 4. And we are having a disjunction of this proposition. So for disjunction of proposition, what was the formula? We are having n to the power n minus nr minus s1 into nr minus s2, right? Divided by nr whole to the power. And what is n here? N is nothing but 2. So it is 2 minus 1 and it is number 2. Okay, so what is our ANR? ANR is nothing but 60, so it is 60 square minus ANR is 60 minus S1 is how much? 42. So this is S1 and this is S2 into 60 minus 4 divided by, it is actually 60. Okay, so you can think of it like 60 square by 60 divide minus 60 minus 42 is 18 into 56 minus 56 divided by 60. Okay, so it is nothing but 60 minus this is 6 10, this is 3 and 5 28, right? So this is nothing but 28 into 3 is 60, 84 by 5. So it's nothing but 60 minus 16.8, right? So it is nothing but 41.2. I'm sorry, it is actually 43.2. 43.2. So this is your size. So the size of the query, so the estimate size of the query will be how much? So the estimate size will be 43.2. So this kind of question you may get in the, so actually this kind of question is given in 2020, 2021 first paper. Paper 1, this kind of question was there. Okay. So just practice some 5 to 10 questions on this and you will be very much familiar with the formulas. Okay. So this much for today and let's try to prepare and try to solve as much as questions, get previous year questions and keep on giving the test series. In GHG there is also a test series and it is having a minimum cost. So you can obviously think of that, of giving the, it is having actually 799. It is actually of 799. The test series is costing you only 799. So I will recommend you to go for this test series because it is not only having the previous year questions but some very well formulated questions like this. This kind of questions will be also be there. You cannot find it anywhere in the you cannot get it in kind of textbook. You can get this question. So I would suggest you to go for this test series. You can get it for the minimum price. So let's prepare and let's get 2022. Okay, thank you.